My name is Yasemin Somuncu. I am rather a new member of the Passive House family. Yet I have had the privilege to meet great contributors. I believe that I took the right step to be part of this big family, and I hope to be a contributor like my colleagues. Dear guests, at the 6th session of Passive House Conference within Zero Build 20, we will be discussing Passive House residential buildings and market development with my distinguished speakers from Greece and Netherlands. Can you please unmute? Can you please mute Panos, Pavlos, and Leonidas?
Hello.
Stop your microphones. Thank you. Mr. Leonidas Nassis from EIPAK, Mr. Pavlos Michos, co-founder 02 Architecture and Mechanical Engineering, Mr. Panagiotis Papassotiriou, Director in Studio 2 PI Architecture, and Associate Professor Erwin Mlecnik from Department Management in the Built Environment, Faculty of Architecture and the Built Environment, Delft University of Technology. Our session is going to be 90 minutes. The first 70 minutes are allocated for our speakers' presentations. The discussion part, which is going to be around 20 minutes, is going to take place at the end of the session after all presentations are completed. We kindly request you to write your questions to the chat box at your screen, so at the end we can share questions with our speakers. Should there be any questions left unanswered due to time restrictions, you can direct these questions to speakers through their LinkedIn addresses, which are available on forum website. You can follow simultaneous translation of this session in Stream 2. Before we start, may I kindly remind all our participants to keep their microphones muted so that there will be no background noise during the presentations. Our first speaker is Mr. Leonidas Nassis. Mr. Nassis is an architect engineer and is the founder of the Elan Sustainable Architect PH Design Architectural Studio, a studio that offers innovative solutions that aim to improve its clients' quality of life in both new and existing buildings through minimizing negative impact on the environment and maximizing energy savings. Leonidas has gained notable work experience in several international offices, including Ashsakula in London and Metesims in Saloniki. Along his diverse academic profile, which has helped him develop a holistic approach around the design process, his latest work focuses on the relationship between the built space and its environmental impact. Leonidas' skill set allows him to lead the complete cycle of implementation, starting from the initial design conception to the on-site completion for various project types. Starting as a certified passive house designer since 2016, he undergoes continuous training regarding passive houses and nearly zero energy buildings design and construction methods, which allows him to find efficient solutions to problems, pay attention to detail, deliver to the point, quality architectural results on time, while also taking into account potential limitations. Today, Mr. Nassis is going to present Passive House in Ceres, Greece. The stage is yours, Mr. Nassis.
Thank you very much for inviting me in this great forum. Actually, I would like to share my screen now and to check my presentation. Do you see it?
It will take a few seconds. Now it's coming. Yes, perfect. It came. This stage perfect. Is yours.
Hello, my name is Leonidas Nassis. Miss Yasmin introduced me very well. Thank you for your good works. I would like to present my first passive house I did 4 years ago in Ceres, Greece. Actually, I'm an architect. I worked in Thessaloniki with my own office, sustainable architecture and passive house design. And Thessaloniki is the city where I was born and working and live, actually. This is the first house I did. some things about the location of the building. Ceres is here. I don't know if you see my pointer. It's located in northern part of Greece, where the climate is hot and humid due to summer months and really cold and not humid at all during winter. The location of the building is outside Ceres in Lefkounas, in the town of Lefkounas, a small town, and the plot is over here. The orientation, actually, we have the plot here in the olive trees, where we have a really steep inclination, viewing, I'm sorry, what is that? Viewing east. The south is here on the street, and at the west side of the plot, we have a hill with evergreen pine trees. And I'm going to explain later about the whole orientation of the building and how the whole design is dependent by it. The PHPP verification tab is actually the tab where you can see all the final consumption, energy consumptions of the building, where we succeeded to have under 15 kilowatt hours per meter squares for heating demand and actually the same for cooling demand, fulfilling all the criteria of a passive house. On your right, you can see. A few things about the plans of the house. Due to the steep inclination, as I told you, you can come in from here, this is the ground floor of the plot, when you can see the kitchen, the dining room, a small office, and the closed parking. At the upper floor, in the second floor, you can see all the private spaces of the 5-member family, 3 rooms and 1 master bedroom with its own cloakroom, bathroom, and 1 shared bathroom for the children. While on the ground floor, you can meet a guest house, a big living room with a music studio, and actually with a mechanical area where everything is installed. And outside, the whole pergola with a big veranda. I forgot to tell you here, where you can see the red dashed line, that this is the thermal envelope of the building. And actually, where this is intersected by another building elements, of course, we have a thermal bridge, so you can see how we eliminated the most of them. Of course, passive house is based on 5 basic principles, which are thermal insulation, passive house windows, ventilation with heat recovery, airtightness, and thermal bridge-free design, which I'm going to analyze them step by step later on. Starting with my first principle, which is the thermal insulation, we managed to succeed the U average of the whole building envelope of around 0.16 watts per meter square Kelvin, and I'm going to analyze some of them, how we achieve them. First of all, regarding the exterior walls, we use the 25 centimeters of bricks with a lambda value of 0.20, having a final U value wall of 0.14 to 0.17, depending on what building element we have behind the insulation, brick or concrete, of course. Outside, the whole approach is to wrap up the whole building with 20 centimeters of insulation. For exterior walls, we use the 20 centimeters of stone wool with lambda 0.36 watts per meter square Kelvin, while for the roof and the basement walls, we use the XPS with a little bit lower lambda of 0.34 watts per meter Kelvin. Of course, in the basement slab, again, 20 meters of XPS. And let's see how we manage to eliminate, not to eliminate, but to decrease the thermal bridges. I'm going to show you some of them out of 2025 I calculated with the software to have my final results. Starting with the foundation walls, what we did is just to cover with 5 centimeters of XPS to all of the foundation walls and perimetrical walls outside and inside the building, so that to decrease this one, achieving a C value of minus 0.62 to 0.1. Later on, this is a nice one in a cold area, in parking area, where this is the first floor and this is the basement floor. what we did just to eliminate this one is to extend the insulation at around 620 to 80 centimeters, so that if you see here, this is the floor and this is the roof, so that to achieve even a minor thermal breach with C factor minus 0.054 and 0.028. Accordingly, in studio parapet, in the first floor, let's say, we wrap it up with XPS, achieving really low values of C installation bridges. Again, in the balconies, what we did is just to lower down the balcony slab for 5 centimeters, so that we wrap it up with above and underneath with 5 centimeters of XPS, and to decrease by a lot of watts the thermal breach. And finally, again in the roof parapet, the same rationale we followed. Yes, and again one more, the roof cantilever above the balcony is this one. We use the same story. Special attention also is given to certain architectural elements, such as this metal cantilever for the south windows, where we would like to decrease the surface thermal breach into a linear thermal breach. Here you see, by screwing with 2 screws inside and out and behind the metal plate, so that we cannot leave the whole metal plate attached and give all the heat or cold penetrating in our beam. Of course, the exterior constructions, such as stairs, they are independent constructions. They don't attach or bond into our building. They are separate constructions that are sitting on a steady soil, so we have no thermal breach at all. The same stuff is done with the veranda, but I don't have any photo now to show you. The third principle regards the passive house windows. We use the Aluplus Energeto 8000 with a really low UF value, lower to 1 watt per meter square. And regarding the glass, we use triple glasses with UG value 0.5 and solar factor 54%. The same rationale with the long sliding door from ground floor to veranda, which was 550 long, and the same really good UF 1.1 watt, and actually the same triple glass. And of course, for all the roller shutters, we use the airtight ones and really good insulated, having a value under 0.75 watts per meter square Kelvin. Okay, no discussion about the spacers. Of course, we use the passive house certified ones with really low values of installation glass. And the whole installation of the windows is done according to the passive house standards. So they are installed with strong metal corners at the lateral and the bottom sides, as you can see here, so that we achieve really zero installation thermal losses. The doors of Alumil, 3 doors one in garage, one in studio, and the main door by Alumil, having a U value and below 1 watt per meter square Kelvin. The fourth principle regards the airtightness, which is achieved having a value of 0.50. The limit of passive house is 0.6 air changes per hour, so we did it. I reckon that in Greece it's a little bit easier to achieve this kind of air tightness in the building because we use the plastering. Of course, we used airtight tapes for all of the windows and doors everywhere. And firstly we installed, then we use the tapes, and then we plaster again all the sides of the windows at the bottom and the backs. Again, some tapes for ducts, and really pay attention to all the boxes, the electrical boxes with a lot of plaster around them. You can see now how it's done, finally. It looks like really nice, really neat. And for windproofness, we used the roof membranes, which are breathable and, of course, waterproof. Finally, regarding the fifth principle, the ventilation with heat recovery, first of all, we used a subsoil heat exchanger, which is doing the pre-air condition of the fresh air. Imagine that instead of importing the fresh air during the summer period with 30 or 35 degrees outside, it's better to import it through the soil, which is the yearly average soil temperature is between 16 and 17 degrees. So it's better to import it through the soil, so having finally a nice exchange and have it at around 23, 22, something like that. Again, the same happens during the winter months. If you see now the ground floor, you can see all the systems, the ductware and all the planings with the air conditioning air from the heat pump. Actually, this is the mechanical area. This is the ventilation unit where the subsoil heat is penetrating this part of the basement retaining wall. All the red ones are the extracts, and all the blue ones, or the blue lines, you can see the inlet, air. How it is now, I present you a photo of how it is and how later it was done with a gypsum board ceiling. Again, for the first room with planings and all the roots of the ductware, how it was and how it's done, and finally the second floor. The architects, I think, they have to pay attention to everything before the construction, because otherwise there's not enough height for them to cover up all these elements. And now I would like to do a comparison between my house and, let's say, the same house with different quantities of materials in the same area, in the same orientation everywhere. Of course, in the climate in the town of Lefkonas, everything the same, but this is actually how it looked like, not in the hill where my house is located, but but in the rest of the town. So actually, you can see always on your left my consumptions and what kind of material I used versus, let's say, if I would have used, let's say, a 9 centimeters of insulation instead of 20, I would have 18 kilowatts per meter square more energy consumption. Again, if I had 4 times the thermal bridges I had, I would have 14 kilowatts per meter square more consumption. If I would use a second double glaze windows with lower values of UF and UG, 6 and 6 for heating and cooling kilowatts per meter square. If it wasn't airtight enough, I would consume more energy by 4 kilowatts. If I didn't have the subsoil heat exchanger, the one I told you in the beginning, then I would spend more money for energy again. And finally, if I didn't have a heat recovery ventilation, something that it couldn't have happened in this kind of house because it's so airtight that you need always to open the windows so that you have let fresh air inside. So you'd have more energy spending by opening always the windows. By doing an overall of the whole comparison, you can see that the passive house consumes at least 1/5 less than a new building of energy. You can see this is, and this is open, let's say. This is actually the energy. The red one is the energy of the house, of my house, while this is the energy of a house that actually now you can build according to the law in Greece, and it should be category of B, energy category B, so you can build it legally. You see, I mean, it's almost 5 times more energy consumption. But I would like to tell you that all this I tell you before, demand an initial capital cost that you need to spend in the beginning, and so that you have a payback after 5-7 years of using the house by not spending at all money for energy consumption. So I would like to conclude with my presentation by giving you some, let's say, tips that are based on, of course, the bioclimatic design, which, of course, passive house is based on, in order to achieve less energy consumption without spending money, let's say. For example, what we did is to eliminate the whole north windows of the house, the north, so we don't have even one opening. To optimize the west windows of the house, these are all the west windows of the house. Actually, these photos are taken a week ago in Paris. This is how it looked like now. This was an old one. You can see nothing is ready. And I'm gonna explain later why is that. And now, what I forgot to tell you by the beginning is that I started this work, let's say, this design for my clients before being a certified passive house designer. So what I did is to pause the whole design process after a discussion with my clients, and to start my seminars and giving finally my exams. It took me 2-3 months to finish this procedure. And after that, by starting using a PHPP better, I understood better about the energy consumption and how to handle it so that I have less. And by the beginning, I had, let's say, a solution, an architectural solution like that. I had 2 rectangulars parallel one to each other. When I then rotated the second biggest part of the building towards to the south, what I achieved is that I had less summer solar gains during summer. I had bigger solar gains during winter. And according to that, first of all, I was protected about the solar gains during the summer period because of the whole, let's say, hill with evergreen pine woods that were located here. And after that, in any case, I wouldn't have solar gains during winter because of them, because they are evergreen. So what I did for west windows is just to make the dimensional so that to provide me enough light for all the secondary rooms I had here in the west, like cloakroom, the staircase, the small bathroom, and the other bathroom of the house. Of course, a big role plays the shading, especially in Greece, for saving cooling demands for the house. So if you see now the south view of the building, this design doesn't happen by accident. I'm sure you about that. Everything is designed after a lot of experimentation about the depths, about the dimension of the windows, the depths and widths of cantilevers, everything, the dimensions of the building, and so that I have a equilibrium that provides me with a bigger amount of solar gains than solar losses. And finally, you can see if I do this final comparison about the no capital costs optimizations, what I gained it's 3 kWh per meter square of heating and 6 about the cooling, because I did very well my design about the shading, the south shading of the building. Now, can someone tell me that, okay, you paid so much money and you saved 56 kWh per meter square, but I can tell you that it's more difficult. It's easier for having a building and to lower down its energy from 60 to 20 kWh per meter square than to 20 to 15. So I was doing like that, 16, 19, and I couldn't use more insulation, more ventilation, more stuff, machinery stuff and stuff. So I just tried to check with my orientation to a little bit change it so that I can have this amount of energy saved. This is really crucial, I say you. I'm sure about that, about the 3 last kilowatts. It's really difficult to achieve them. This is what I would like to tell you. I hope that I was really analytical for those who didn't know a lot of things. I tried to analyze step by step the whole procedure of the design and construction and what I did for this house. Yeah. That's it. Thank you very much.
Mr. Nassis, thank you very much for this very interesting and in-depth presentation. Can you stop sharing your screen, please? I felt myself both in the design stage and in the construction stage. Very clear, transparent information, very much detailed photos of the construction. Thank you so much. Anything which was in my mind during our training sessions now is completely there. Done. Thank you so much. And now our second presentation has 2 speakers, actually. Mr. Panagiotis Papassotiriou, Panos, and Mr. Pavlos Michos. So I would like to introduce our speakers. Panos is a licensed architect and passive house designer after the completion of his first passive design project in Napoli, Greece. Panos studied architecture at the UNL, London Metropolitan University, where he completed RIBA 3 and IRB registration. Following 4 years working at PCKO Architects in London and gaining a vast amount of experience in various aspects of the architectural practice, Panos decided to establish Studio 2P Architecture in Argos, Greece in 2010. He has won a number of awards and has participated as guest speaker in various conferences and forums. Most notably, he won in 2015 first prize at Domes Architect Awards for Villa Melana in the category Best First Building by a Young Architect of the years 2010-2014. And in 2020 won in the German Design Awards special mention for Neon Bakery in the category Excellent Architectural Retail Architecture. Pavlos is a licensed mechanical engineer and certified passive house designer. Pavlos studied mechanical engineering at the University of Sussex, where he gained a Bachelor of Engineering and a Master of Science in Mechanical Engineering. He continued his education at the University of Nottingham, where he completed a Master of Science in Sustainable Building Technologies. He is co-founder of 02 Architecture and Mechanical Engineering Practice, providing a wide range of services combining the traditional mechanical engineering with concrete awareness of building sustainability. He is a registered engineer with the Technical Chamber of Greece since 2012 and an energy assessor certified by the Hellenic Energy Inspectorate. He is also a member of the American Society of Heating, Refrigeration and Air Conditioning, ASHRE, and Hellenic Passive House Institute. Today, Mr. Panos and Pavlos are going to present us from zero to hero. Stage is yours. Thank you.
Thank you very much. I'm Panos. Thank you for the presentation. We are very happy to be here, of course. Let's try to share the screen first. Share screen. It doesn't seem all right.
It takes a few seconds.
Entire screen. Allow. So, can you see us? Can you see the presentation now?
Let's wait a few seconds.
Okay. Probably you can see that we're not in a passive house building because the weather in Greece is very hot at the moment, and the third temperature here is probably beyond the 27 degrees at the moment. So
Panos, not yet.
It doesn't seem to show.
You have not opened your presentation yet.
Okay. I think I have. Yes, I have. Open the presentation. StreamYard. Share screen. Okay.
Let's see.
Should
Let's
be
wait.
okay now.
Yes, we have the presentation now, and if you go to the presentation button, it's fine. We
Now
see
it's
the
fine,
small
yeah?
slides at left side and the big slide at right. So if you can put it at the presentation position.
Is it better
Let's
now?
continue like that.
Okay, let's say. Okay, my name is Pavlos Papassotiriou. I'm the architect of the project we will be presenting. First of all, obviously, we'd like to thank the Hellenic Passive House Institute and especially Stefanos Palatjas for the invitation to be here today, and the Zero Build Forum people for having us and the organizers. And we are very happy and very excited to be here and presenting our building. It is it's a moral satisfaction and great joy to show to people what you try to do, what you try to achieve. We will speak about the retrofit of an existing old dwelling with a proposal consisting of a new extension to the side and the top of that building. So go to, and this is the house as we will be presenting it, and this is how it's going to end up to be. Now, this is the team that was responsible for the design and implementation of the project. Pavlos, at the second part of the presentation, will talk to you more in detail about the methods and techniques we followed to achieve this passive house certification by referring to the energy benefits of construction and what we call a responsive addition to the city. I will focus more on the internal process that we followed as a design team to decide on the implementation of the standard and also some of the difficulties that this construction had in terms of its execution, and there were quite a few. We thought, of course, that the colleagues who are going to be seeing the presentation today will be interested to see how this idea of passive house and the choices we take in order to achieve the passive house standard could affect the whole process. Now, this is the before, as you can see, the existing condition. This was our first attempt as well. As Leonidas said before, this was our first attempt to design and construct a passive house building. I have to admit that despite my exposure to passive house design, I was quite skeptical at first about whether the passive house design could be applied in a Mediterranean climate. Apart of that, I was skeptical as well about what would be the cost for that project in comparison to a cost of a similar conventional construction. As an architect, I have to say that I had another fear. The fear was maybe was greater that at what extent the architectural freedoms that we normally have on the design of the building will be limited and will lead us to a result that would be aesthetically not as satisfactory as we would like them to be. You can see the existing building, and this is what we promised to take from zero to hero, as you can see in my title. The building had a footprint of 83 square meters, built in 1963, just below the castle of Akronavplia. The southern border of the plot is the walls of the castle, which sits above us. And you can see the location here. In this building, we were invited to design an extension to the side of the existing ground floor, as well as a self-contained first floor flat. In its final form, the building consists of two self-contained apartments, ground and first floor. Our decision from the beginning was to apply the standard, but this was to be done with as much effort as possible, as I said, not to negatively affect the design element. These are small but very important safety valves that we use as architects to move freely within a pattern that addresses certain issues and requirements by the client, by various public bodies, etc. Having now applied the standard in both design and construction, which you will see in the next slides, I must report that the resulting limitations are to a large extent proportional to the limitations of a conventional construction. We did not face or encounter any particular problems in applying the standard. beyond what was expected, to be honest. I mean, it wasn't something that we did that we felt it was taking us far away from a conventional construction. For example, the thickness of the insulation in the masonry and the roof are compensated by the beneficial provisions we have here in Greece in the legislation in terms of the amount of insulation we use, as well as the internal intakes and infrastructure for the mechanical ventilation do not take more space than those of the conventional heating and cooling systems. Why I mention this? I mention this mainly for an important reason that I believe should be analyzed in order to have greater success in spreading passive house to a wider audience. It goes without saying that a successful design can be more easily accepted by the general public. And sometimes it can often change the way we think about a particular product. Take, for example, what happened with the iMac 20 years ago, or with the Tesla cars, with the electric cars that we see today. These are very solid examples of how the public, by seeing a product that is aesthetically pleasing, can want and will try it more often and in greater numbers. So, despite whatever good intentions we might have, if the product is not aesthetically pleasing, it will never reach its full potential. Of course, here someone might say that you are an architect and you refer to the design as the most important element, but the essence counts, and not the aesthetics in the sense of pretty and beautiful, etc. I think we must accept that substance is something that does not represent the same thing for all people. For our part, we must educate our clients about what is beautiful and what is aesthetically pleasing. These are concepts that are being understood by more than one sense, a human sense. For example, it's not only what the eye can see. We must try even harder to offer same results that the conventional buildings offer, and even more so that in addition to the high energy efficiency and comfort that we produce, we can have a design that excels in that aspect too, as in every other aspect that I've mentioned already. Borrowing from Plato's many references to the issue of aesthetics, we see that he refers to the beautiful as proper, as well as the beautiful which refers to the pleasure for the eyes and the ears. I think we can do both. Our eyes deserve the beauty of Plato, as the environment must always play must always be the supreme good in which we base a sustainable future for all. This is a CGI image of the final building. Whether we did it or not, it will be proven by the result. But surely we didn't feel at any point that we sacrificed design, ergonomics, our materials, our generic strategy in order to satisfy the standard. Instead, we used it as an additional parameter that enriched the result both aesthetically and functionally. End product, almost there. We have the surrounding area to be finished soon. The difficulties, a few difficulties, especially in this building, were certainly more than we could have had in a similar building but located in a different area. I would like to briefly mention some of the ones we encountered in terms of their design and construction management. By doing so, we can see, first, the passive standard can be applied to the most difficult projects or construction sites, and that the standard can work many times as a positive alternative to the conventional way of construction. You can see the photos when we stripped down the existing building and what we faced. What were the difficulties that we faced there? Archaeology. As it is understood, the special weight of the old city of Nafplio, which is a very important city for the history of modern Greece, is reflected in the limitations in the architectural composition and in the morphological character of the final building. Archaeology set restrictions, and rightly so, on the height of the building, which led us to very small internal heights of about 2.65 meters. Nevertheless, we managed to have exactly the same result we wanted with a combination of decisions that were applied on the PHPP report, which Pavlos will mention in his presentation. this is I would like to say that this is one of the very positive elements of the passive house model, is the possibility through combination of decisions to change in different data to have similar results. This gives a great amount of freedom to the designer. Access to site. Arriving at the small park inside the castle, we enter a narrow road that leads to our building. In order to do that, we need to go through an old stone arch area, which is 2.5 meters wide and approximately 3.3 meters high. It is understood that this creates huge problems in the supply of materials to the project, as well as in the handling of machinery that can pass through the archaeological site. I mean, you can see the photos from where the concrete was set, the concrete pump was set, and it's traveling 37 meters in distance and 19.5 meters in height through some of the loopholes of the castle to reach the final concreting surface. Structural issues. The existing building was made of load-bearing masonry, and as a result, our interventions had to be done on a substrate that by quality, time and construction characteristics had to be reinforced and reconstructed in full. I mean, we jokingly say between us that the whole procedure was like an open heart surgery in which we keep the body alive by changing piece by piece what is obsolete. Reaching the completion of my presentation of the first part, I would like to point out that the design and implementation are independent actions with a holistic character. We should not deal with these stages in a fragmented way, but incorporate them in the same process. Pablo?
Thank you, Panos. Hi, everyone. My name is Pavlos Michos. I'm a mechanical engineer specializing in building sustainability. I'm also a passive house designer certified by the Hellenic Passive House Institute. I would like, in my turn, to thank Mr. Palagias for his invitation on this conference, as well as Mrs. Stathopoulou for her support during the design process. This is our first passive house project, and we are really glad to be here with you today. So, as already mentioned, the building is located in the old town of Nafplio in Greece. The climate zone of this location, according to the passive house classification, can be considered as warm, meaning that the site is both heating and cooling dominated, and Athens weather file data were used for safety reasons. The treated floor area is about 158 square meters, and a number of occupants has been set to 4. You can see an overview of the result, which shows that the heating and cooling requirements do not exceed 13 kilowatts per square meter each, and we are very happy with this. A few words about the envelope. In this project, there are several different wall constructions, which arose either due to the existing situation or for reasons of structural or aesthetic adequacy. The core of the existing construction is made of brickwork, while the south side of the ground floor of the new building is made entirely of concrete, as you can see here, and this is the existing situation. In addition, there are parts of the envelope in contact with the ground, like here, which have been insulated internally due to the existing situation. These weaknesses were compensated by the use of etong, which is a material with a low thermal conductivity. An external insulation of 10 centimeters thick have been applied, resulting to a wall ambient of almost 0.22. Let's continue to the envelope. As you can see here, in the roof, were applied about 25 centimeters mineral wool. To the first slab, about 15 centimeters. And 3 centimeters, sorry, and for the roof slab here, about 15 centimeters. And we have an average weighted U value at 0.24. Due to its location and therefore due to the orientation of the building, the total area of the openings on the north side is 3 times that of the south side. And this fact, in combination with permanent shading, as we will see below, of the south face, due to the morphology of the terrain and the tree planting, constitutes a problem. Why? Because the energy balance of heat losses and gains from solar radiation during the heating season is negative. To reduce the heat losses, triple glazed windows were installed. And to minimize the thermal bridges to more than the half by moving the windows to the middle of the opening, like here is 0.061 and here is 0.028. And this was really important for our results. Shading. Here you can see that the shading on the south side here and there of the building, which significantly reduces the solar gains, especially during the heating period, while the large area of glazing on the north side increases the need for cooling, mainly due to the diffuse radiation during the summer. And part of the solution to the problem lies in mechanical ventilation. We use 2 Wolf units, one in each apartment, with efficiency of 25%. And was that enough to reduce our needs to the desired levels? No, since the heat losses, but mainly the cooling loads, remain at high levels. So, for this reason, we installed a ground air heat exchanger, the characteristics of which you can see in the relevant table here. And it was observed that the heat exchanger was significantly effect on reducing cooling loads compared to its effect on heating demand. As the efficiency of the heat exchanger increases, so does the need for cooling. And this allows us to increase the G value of the glazing to 0.6, which in turn leads to an increase in solar gains and therefore a reduction in thermal needs without the need to further improve the thermal insulation of the building to reach the criteria. As you can see here is the ground air heat exchanger. And finally, we successfully completed the blower door test criteria for a passive house new build. And the average air change rate of 50 Pascal is 0.64, as you can see here. And the PHPP results, at this point, we can have a look at the energy balance for heating with both annual and monthly method. And the solar gains here are almost twice the heat losses through the window area, according to the monthly method here. And I would like to say that the heating load remains below 2 kilowatts for each apartment. No, sorry, for the whole building, as well as the cooling load. And thank you very much. This is the cooling loads. And thank you.
Okay.
Thank you so much for this fantastic presentation, Panos and Pavlos. It was delightful to go through the presentation. As you mentioned, it's very important to find a balance between the essence and the aesthetics. We are very lucky to live on lands where we have fantastic cultural heritage from our ancestors. It's very important to combine and give the proper respect to our heritage buildings and also introduce the technology so we can find the proper and perfect comfort level. It's a very
fine balance.
Very fine
yes,
balance.
Thank you so much.
Thank you so much.
And one final thing, just to say that we managed to do that on an old city, which is important, that passive house can be applied in the old towns around Europe, because we have plenty of them, I'm sure. Thank you very much.
Thank you.
Yes, it's so important to pass over this message, because people can easily be tricked that when you are dealing with standards, with new technology, you have to get rid of the past. No, this is not the fact. It is very important to find that balance, that very fine balance. So thank you so much.
Thank you.
We have to spread the word out more and more, for sure.
Thank you very much.
Thank you.
Our fourth speaker is Associate Professor Erwin Mlecnik. Dr. Mlecnik works at the section Real Estate Management of the Department Management in the Built Environment, Faculty of Architecture and the Built Environment. He has more than 25 years of work and research experience on sustainable construction and innovation. He is also a member of various working groups of the International Energy Agency. He obtained his PhD degree in 2013 with the thesis Innovation Development for Highly Energy Efficient Housing. He was founder, coordinator, and senior expert research development at the Flemish Passive House Platform, a non-profit organization that is specialized in the dissemination of knowledge for the realization of highly energy efficient buildings. He also used to be the research and development responsible at the Energy Durzam and at the Engineering Office Genergy CVBA, which specializes in the development of energy services. Before that, he worked at the universities of Palermo, Montpellier, and Brussels. Today, Dr. Mlecnik will be presenting lessons from the passive house market development in the low countries. The stage is yours.
Thank you, Yasemin, for this introduction. I will try to share my screen.
Yes,
so I think you can see this now. Yes. So I am an engineer architect, but unlike the previous speakers, I will not talk about design, but about the market, especially trying to look back at what happened in the Low Countries, where the passive house was already introduced a long time ago. So my presentation will be very straightforward. I will tell you a bit more about the passive houses in the Low Countries, Belgium and the Netherlands. I will talk to you about how we investigated the market development, what are the lessons learned from that. So compared to the Mediterranean countries, of course, in the Northwest and Central Europe region, we have space heating dominated regions. And of course, it makes sense to reduce the consumption for space heating as much as possible. And therefore, also it makes sense to introduce the passive house standard and limit the energy demand for space heating to 15 kilowatt hours per square meter per year. Unlike the Mediterranean countries, there's usually no specific requirement for cooling. But of course, we also have the airtightness requirements and the primary energy requirements. Now, these passive house requirements have been introduced in the different countries already. So, and this has been leading to quite substantial market development. For example, on the left-hand side, you can see examples in the Brussels capital region, where they had a big program from the Brussels government to stimulate passive houses. On the right-hand side, you can see, for example, a city development in Antwerp, where already in the procurement stage, the passive house requirements were set when selling the land. Now, this is all going very well, but you can ask yourself, why is not everything yet built in passive house standard? So let me first go back to the market development from the beginning to today. And I will try to guide you to this using a theoretical framework, which is a theoretical framework of innovation adoption. It comes from the work of Everett Rogers, who is wrote a kind of a Bible on innovation theory. It's called Diffusion of Innovations. And probably you recognize these types of curves, for example, from the COVID crisis. In the beginning, there's a slow takeoff of the market development. And once we reach, many years later, a higher takeoff, an exponential growth. And then at a certain point, the market is saturated. Now, what's the interesting point of Rogers? In this case, he says that in each phase in time, we are dealing with different people. In the beginning, we are dealing with innovators, people like you in the platform who are really technologically savvy, who know, who are interested in all these technical details and who want to bring innovations to the market. In a later stage, we will be dealing with early adopters because the opinion leaders have to be able to find the innovators in order to progress the market and to spread the message. Then at a later stage, we will be dealing with yet other types of people, maybe not that rich or maybe not that knowledgeable. Early majority phase. And then, of course, in the end, there will always be people who will never, under no circumstance, implement an innovation. So what's the interesting benefit of the theory? It says that each of these categories, you are dealing with different people, and it's very difficult to bridge the gap in the market from the one category to the next. Luckily, there are some guidelines, made by Rogers. For example, it identifies innovation characteristics. Innovation characteristics, these are all also confirmed by different studies. For example, the hypothesis that the higher the relative advantage of an innovation, the more likely it will be adopted. So if you can show benefit, relative benefit for the adopter, then it is more likely that the adopter will adopt. But it's not only a question about relative advantage, it's also a question about simplicity. The more complex an innovation is, the less likely it will be adopted. Also, trialability plays a role. If you can test an innovation before you really adopt it, then it is more likely that it will be adopted. Visibility, as you know, in your platform, it is very important to make demonstration projects visible. And the more visible they are, the more likely they will be adopted. And compatibility. And that's a difficult one, because that means that your solution, your innovation has to be compatible with the viewpoints of different types of stakeholders, and with the current market conditions and with the current policy conditions. So by looking at these factors, and also by looking, for example, at the way strategic niches develop, I can illustrate this for you regarding, for example, the passive house development in Belgium. How did the innovation phase start there? Well, actually, before 2002, there were no passive houses in Belgium. And it is mainly because the passive house platform was erected in 2002 with 18 different types of companies that the passive house came in the picture. We spread the message in the beginning, and that's a nice anecdote for Turkey. This graph we showed on many occasions in the beginning. It shows the thickness of the insulation in walls in different countries. And you could see at that time, the Scandinavian countries were excelling, but Belgium was really lagging behind. And we always said, even behind Turkey, which is a Mediterranean country. Yet, that convinced a lot of people to start to doing something and to start building up a vision. What do we want to reach with our platform regarding passive houses, regarding the network itself, the way it is constructed using a multidisciplinary approach, small and medium enterprises from different directions, different types of stakeholders, and also providing the learning, of course. Now this led in 1 year later to the first demonstration projects. And these were certified then again 1 year later. So these were a terraced house in Ghent and a single family house in Limburg. Now looking back at these characteristics in the innovation phase, we saw that it was the relative advantage for the people who participated in the platform was relatively high because they could learn from each other, and they could especially also learn from the demonstration projects. They were being followed up every week almost. Now, it also became obvious in the innovation phase that this was not simple to build a passive house at that time. Actually, it was all the components were not yet available on the Flemish market. Regarding trialability, of course, the demonstration itself is a nice example of trialability. The visibility was very high. We promoted these as houses without heating, and that gave a lot of response in the journals and so on. On the other hand, the compatibility, there was already a problem in the beginning, because what was being built there was not really compatible with what was being built at the moment in Belgium, even to the point that the building permits were refused in some cases because the officials didn't believe that such low energy performance could be achieved. So in the early phases, we developed this vision, network, and learning towards the innovators, people like you. Now, at the start of the early adoption phase, that was a bit more difficult. So we had to reach out to the opinion leaders. We had to make sure that quality was achieved. So in 2004, a local passive house certificate was launched. Now, the fact that the certificate was there also gave confidence that grants could be issued, because these certificates were issued by a non-profit organization. And this non-profit organization could be supported by policy actors, while in practice, policy actors cannot support individual companies. First grants were municipal. They were not very successful. And also energy providers provided some grants, and also that gave not that much response. Yet it did give a lot of response in the number of members of this platform. Here you can see how this evolved up to 260 members in 2007 in total. And of course, the higher the community, the more visible things became. So relative advantage was increased because things were made because of, for example, money benefits. The simplicity was still complicated because now we were introducing a certificate, while at the same time the Flemish Energy Agency was launching its own energy performance certificate. So we created a competing market. And in fact, in the end, if somebody wanted to build a passive house, in the end they had to provide the 2 certificates, which gave a lot of extra work, of course. Visibility and trialability were high, and as I said, compatibility, especially with the policy, was a bit of a problem. So in that phase, the platform itself had to deal with lowering the complexity mainly and providing better compatibility. So passive platform did a lot of lobbying, for example, with the policymakers to try to integrate certificates, for example, to try to make the things less complex. Now, still we were not in the early majority phase, and because a large portion of the population already heard about the passive house, but most of them did not really consider it if they could also build, for example, a lower energy house. This changed a bit in 2007 because in the end, the passive house platform could convince a lot of people to have an income tax reduction for people who are building a passive house. So during 10 years, people could get a reduction of their income taxes. Now, suddenly this became visible as a benefit for all citizens in Belgium. And that was really something that also led to a breakthrough in the market. The relative advantage was then again increased. Was it made simpler? No, because in the end, we now have all these different types of subsidies and local grants and income tax reduction and real estate tax reduction. And all these different reductions were different in different regions, even different cities. So this didn't make it really simpler. The trialability was also going a bit down because it became more standard. The visibility was, as I said, very high. The compatibility now with legal issues was also increasing. So there were other jobs to do by the passive house platform in that phase. Now that's where the good news ended. In the end, the gap to the late majority phase was not really bridged. Why was that? First of all, there was an EU policy introduced, and the policy introduced the nearly zero energy buildings. So passive houses could be considered as nearly zero energy houses, but in the end, also low energy houses or zero energy houses or net zero energy houses could be considered as such. So that gave a lot of discussion in Belgium, particularly because energy was a responsibility of different regions. So the Flemish regions and the Walloon region and the Brussels capital region had the opportunity to interpret this in a different manner. But there was no compatibility in the end. While the Brussels capital region introduced it in the legislation, they were not powerful enough to convince the other regions to also do that. So in the end, the energy performance certificate, as it was introduced in Flanders, kind of won the scene. But also not only on the policy side, but also on the supply side, there were concerns. For example, we didn't manage to really integrate the very big companies. And also we didn't manage to integrate the project developers, for example. There was a high focus. These people focus more on larger markets and on high return on investment. And that was problematic. On the other hand, there was also competition, especially in the non-residential sector from other certificates. You all know the LEED and the preempt and so on. And that made it also difficult for investors and project developers to really engage for the passive house standard, because they are also working on mixed projects, which include residential and non-residential. On the level of the researchers, there was also something happening. These were gradually focusing on newer developments, such as net zero energy buildings or energy positive districts, energy flexibility, up to now even circularity. So the response in the research sector also diminished. And then there is also on the demand side, there was a problem because the demand was shifting. While in the beginning of the platform, there was still a lot of new construction. Nowadays, in the low countries, the majorities of the construction works are renovation. And there's a high preference there for phased retrofits compared to integrated retrofits. So while the InnoFit standard provides some response to that, we saw in practice that the projects you see here on the left-hand side, these renovations are different types of buildings, which have sometimes very complicated details to make thermal bridge free. So we had a large demonstration project to illustrate if passive house standard could be applied on such buildings, and we came to the conclusion that, well, 15 kilowatt hours per square meter per year was not feasible for all types of renovations. Some of them were on the level of 25 to 30 kilowatt hours per square meter per year. So in conclusion, I've tried to illustrate you the different phases of the market development. We now know that there are gaps between these different phases, and as a passive house platform, you really have to work on bridging these gaps. So the passive house houses in the Brussels region really reached this early majority phase, and now there's a kind of decline in interest. In Flanders, actually the nearly zero energy houses took over from the passive house development, and in Flanders also the certificates for passive houses almost disappeared. So, but they reached the growth phase. Now, regarding the passive house renovations, as these were introduced much later in the market, we are still in an introduction phase. Well, I promised to tell you something about the low countries. There's another low country, the Netherlands. Just briefly, I will give you some review of the barriers that were encountered in the Netherlands regarding the passive house market development, just to show you that this evolution is very different in different countries. For example, the market in the Netherlands is very differently structured. While in Belgium, there are lots of single-family houses, and the market is dominated by people who build their own house. The housing market in the Netherlands is mainly dominated by housing associations and larger companies. So while you might think that this would lead to faster adoption because they have a large building stock, in reality, this is much slower because these housing associations also have a very complex internal structure. It's not sufficient that one person is convinced within such a company to make sure that this goes to every level in the company as something that is needed. Also, the guidelines that were developed in the Netherlands by Stichting Bouw Research, they gave also a bit their own interpretation on the passive house standard, and they also relaxed some requirements, for example, regarding the window frames. But I think the most influential in the whole market development of passive houses in the Netherlands was in 2008. There was a scandal in Vathorst. There was a large complex being built of apartment buildings, and people were experiencing health problems there. And in the end, this was attributed to the mechanical ventilation system with what happened was actually that there was very poor installation of the mechanical ventilation systems. Even some tubes were still closed during operation, so people didn't even get any fresh air. But while this was a one-time problem, this was reflected so much in the media that there is a large aversion now in the Netherlands towards mechanical ventilation systems in residential buildings. And also in the policy level, the Netherlands was really lagging behind compared to Belgium. The passive house was, for one instance, introduced much later. And now also the nearly zero energy buildings definition for the Netherlands is still not even decided for the moment. They're still working on it. There's still a lot of discussion on how to calculate the overheating of a building. And at the same time, the market is already introducing circular housing concepts and zero on the meter renovations, which are competing again with passive houses. So that brings me to my conclusion. I think if you want to develop this in Turkey or another Mediterranean country, you really have to think about strategic management to develop this niche. And that includes the development of a strategy vision, a multidisciplinary network, and actor-type oriented learning. We experienced that peer-to-peer communication is really key to achieving knowledge sharing. Based on the market signals, these local support networks should constantly review what they are doing, especially to bridge the gaps between these different phases, and constantly review how they can increase the relative advantage, the visibility, the trialability, the simplicity, and the compatibility. Worldwide, I think the passive house is now in a critical diffusion stage. There is an increase in competing supply concepts. There are many regional policy differences, and the demand itself is also shifting. So what are we doing now at the TU Delft? We are trying to look at this from a more holistic perspective. We know that in the end, policy, demand, and supply have to work together. And what there is really needed now is an innovative policy instruments to support this collaboration, also collaborative business models, and better stakeholder dialogue. And that is needed to develop the market strategies for housing and renovation concepts. This is the typical triangle that we are working on. And as a non-profit passive house platform, you're somewhere an intermediary, either between the private and the public, or between the private and the civic. These business models are very promising. We have been working, for example, on the one-stop shop business model. And again, this gave a lot of interest from different small and medium enterprises to work together using very well-defined value propositions towards customer segments. And in that way, you can really work on targeted market development. So the dialogue is key, I would say. Here are some more references if you want to explore these issues further. That concludes my presentation. Thank you very much.
Dr. Mlecnik, thank you so much for this wonderful presentation. I think maybe we should also discuss about the outcomes of the COVID-19 pandemic, because as you rightly have been underlining, there are very many different certification systems and different targets which are being discussed, proposed by different governments, organizations, and civil society maybe. But also at the previous session, we had a speech about the comparison of the different certification systems, and Passive House has the opportunity to bring us the comfort in the buildings. That is a very, very key element with the heat recovery system and with the natural ventilation. It is a few steps ahead than the other certifications and standards, in fact, because not in the other standards they are looking so much in the comfort, and I think this is going to be an issue which will have to raise and again discuss in further. So I would like to thank you a lot. And I have a brief questions to all participants. I would like to start with Mr. Nassis, please. At your presentation, you have shown us that you worked with mineral wool insulation. And taking into consideration that mineral wool can be affected by rain and humidity, which we have come across at construction sites, that workers who don't have the complete knowledge can just leave the mineral wool on site, and then it gets all the rain, and still that mineral wool is applied to the building. So what would you prefer? Because we are countries where we receive rain. So what is the pros and contras of, let's say, an EPC and a mineral wool?
Actually, why the first reason why we select the mineral wool for our insulation is that for the it's not combustible by fire. First of all, near to, as I saw you, near to our house in the west, there was the pine, the hill with the pine woods. This is the first part. The second is that while we applying the mineral wool insulation, 2 times it was rained, but there is no problem about that, because nothing happened. Of course, I don't know how to explain it. The vapor, there's no any vapor, the M value, which I don't remember now in English how is it. It's like that it's more breathable, actually. It's not like a EPS or XPS. So it breathes. It breathes like the air. It's the M value is 1. So it's nothing to afraid of it. Not really nothing to afraid of it. So first of all, it doesn't absorb the water, and even if it absorbs it, then it take it out after. It's really easy to have it always dry and not wet. It's not like the other kind of insulations. So you don't need to afraid of anything. Actually, in 99% of my works, I use the mineral wool, just for this reason, and especially for non-passive houses, of course, because I would like to breathe, to let the building breathe out of it, and not having all the vapor. I don't need to use it as a vapor barrier.
Thank you so much, because that's important. As you say, the fire resistance is very, very important in very many building categories. Then it should be, I believe, at the construction site, the necessary precautions should be taken. Then there's no problem with it.
No. Gloves, mask, everything for protecting eyes, of course. Everyone was well protected. I know, because it's
Thank you so much.
Bit.
And next question is about the ground air heat exchangers. The return of investment or the ground air heat exchangers, because we had also used such a system in an educational building, and actually the return on investment was not very feasible at the beginning. But then what was decided was that at this basement floor of the building, they decided to place all the student clubs. So the students were coming at nighttime after their classes, and then they were using the spaces for their student radio, dancing studio, or their music club, whatever club. So then the return on investment suddenly dropped down, of course. And that's, of course, a dilemma, because we always, unfortunately, have to show a kind of way that under return on investment, we get these very fancy figures, so we can convince the clients and the big pockets to use these systems. So if we would compare it with a house, with a residence like you have been using, because you use the residence at nighttime. In a hospital, it is again perfect. A hospital is functioning 7/24. Return on investment would be fantastic. So what would you say about using this system in residences? Panos and Pavlos,
am I speaking? I can ask you. I think you are right about the payback period of it, but there are other issues also of using it. For example, during winter months, it's better to precondition the air in order not to have any freeze damage into your ventilation unit. Something that you cannot know. If the degrees of Celsius outside is below 0 Celsius, then you have maybe it's a crucial risk. Maybe you can damage it. So by pre-air conditioning the air through the soil, there is no problem. This is the one. Regarding the payback, if you check again my presentation, you can see that you just save a little amount of energy regarding that. 2 and 5 kilowatt-hours, as I remember now. I'm not sure about that. Regarding all the rest that you gained from bigger insulation or 3D glazing. So you are right. There are other issues. Okay, you pay some more money, but this is my point of view. I didn't check the numbers, to be honest about that, but this is my opinion. Yeah, I don't know if Panos and Pavlos have other stuff to add.
Well, I would like just to say that ground air heat exchanger was a must for our project because we have large cooling loads, and due to the rotation of the building, it was the only way to reduce the cooling loads. And it's very important to know that ground air heat exchangers reducing cooling loads, especially in humid climates. And in this way, we had the opportunity to increase the G value of the windows to gain more, to have more solar gains. Actually, if you hadn't had a heat exchanger, we couldn't find any other way to reduce the cooling loads or to increase the heating gains, the solar gains. Because due to the location of the building, we have some restrictions, like we couldn't have shading or overhangs or stuff like that. And that was the only way to reduce our load.
Just to say one more thing, this is one of the important factors of the passive house, is the versatility. You can alter elements in the PHPP report while you're designing, and you can play around with them, and you can achieve the maximum or whatever you want to achieve. So this is, especially in terms of design, I keep on saying that, and obviously sometimes people, but for us, for architects, it's very important the fact that you can play around with these things, and then you can come up with a design with the result that you want. It gives you a lot of freedom, more than people can think of. I mean, when I was arguing with Pavlos, because we've argued a billion times about the design, various things, he always came up with a solution of how we can have that while, the blue pipes are very nice, but I want them hidden. So, in that sense, he was very nice of that. So, yes, you can play around with elements.
Thank you so much. As we are running out of time, I would like to ask Dr. Mlecnik one question. And I was also, it was interesting to find out that when you were establishing the passive house association in Belgium, you took the companies as members rather than individuals. I think that's a very, very intelligent step, because the individuals have a certain amount of power, but when it's establishment within companies, of course, it is a very different ball game for sure. And I was impressed about the incentives, the tax reduction in 2007. This is something we cannot still achieve in Turkey, in our country, because it's talked and talked for years. People are giving all these good reports and suggesting, but it never happens actually. I mean, taking the action is very, very important. Awareness is different, but the ability to actively take the necessary steps is very different. So how could you convince your government to cut down the tax? Because government earns. I mean, tax is the easiest way to get the money. from fuel, whatever, everything. So this is the very tricky question I would like to ask you. Very interesting answer, and hopefully we can also implement it in our countries.
Well, it was actually my colleague who did all these talks with different governments. What I know is that the demonstration program in Brussels was very influential. And at that time, the Brussels government also had a more green-oriented government. So they were keen on introducing something also because Brussels is the capital of Europe and so on. So as a demonstration program worked very well, the Brussels capital region did have an influence on the national level. So as well as again these engaged politicians and institutes that played a role in lobbying. In the end, I don't know how it was really decided. I think there were in the tax department there were also some people who were interested to implement this. It was not only a tax reduction for passive houses, it was a tax reduction for energy saving houses in general. So you got a tax reduction for low energy houses, for passive houses, and for zero energy houses. And the higher the requirement, the more money you would get for the income tax reduction. So they were kind of experimenting with the three different concepts.
And what is the end result? They are happy, and after this pilot project in Brussels, let's say, has this been implemented in any other country in Europe? Do you know? Do you have any idea about that?
Yeah, there was this. There was a European project called PASREG, the passive house regions in Europe, where the aim of that project was to implement it to spread the word in different countries and regions. So I know some countries also worked on it. Brussels had a lot of impact on decision making in Antwerp, for example. Also in some German regions and some Central European regions. So, but it was never one-to-one replicated. It was always a kind of reinvention in the local context, of course. But in the end, the Brussels capital region also spent a lot of money in this program. They were kind of, the good thing about the program was that there was also money for the architects. Yeah. So 90% of the subsidies was for the people who own the building and 10% for the architects. So that stimulated really the architects to get the knowledge for
sure. For sure. So thank you very much. I would like to thank to all my distinguished speakers, guests. Once again, it was a very, very interesting and very good session for me. And hope to see you in the near future, collaborate, maybe see in other forums, or we'll see how it will proceed from now on. Thank you so much for joining us.
Thank you very much. Thank you very much.
Thank you very much for the invitation.
Bye-bye.